All right, let's begin the Unit 4 review. We talked about this just very briefly in class today, but now I'll work through the problems. All right, when it says list the values for which the expression is undefined, this means, and I've tried to blow it up here, so be patient with me. Find the values that make, the denominator equal to 0. Because if the denominator is 0, the expression is undefined. Okay, so all I have to do is look at the denominator. I don't care about the numerator. So what I do is I take the denominator and set it equal to 0. So in this case, it's just x equals 0. In number 2, I take the denominator, set it equal to 0, but now I have to solve for x. So I add 1 to both sides. That gives me 2x is equal to 1, and when I divide by 2, I get that x is equal to 1/2. That is the value of x that will make the expression undefined. Okay, for number 3, again, I have to set the denominator equal to 0. So I have 3x to the second plus 9x is equal to 0. Now, since it's a quadratic, I want to try to factor this. I notice this is 2 terms, and I do notice it has a greatest common factor. The greatest common factor is 3x, so when I factor that out, I'm left with x plus 3. When I set that equal to 0, I have 2 factors. I have 3x equals 0, or I have x plus 3 is equal to 0. So this tells me that if x equals 0, it's undefined, or if x equals -3, it's undefined. Here I also set the denominator equal to 0. So if I have x squared plus 7x plus 12 is equal to 0, it's a quadratic, so I have to solve it by factoring. Since there are 3 terms, there is no greatest common factor other than 1. The leading coefficient is 1, and it's 3 terms, so what I'm looking for now are 2 numbers whose product is 12 and whose sum is 7. And those numbers are 3 and 4. So this factors into x plus 3 times x plus 4 is equal to 0. So x plus 3 is 0, or x plus 4 is 0. So here x is -3. That makes the denominator 0. X is equal to -4. That makes the denominator 0. Okay, once again, I take the denominator on number 5, and set it equal to 0. It's a quadratic again, so I'm going to have to solve this by factoring. It's a trinomial. There is no greatest common factor, so I'm going to have to do my split and group. So I'm looking for 2 numbers whose product is -20, and whose sum is -1. And those 2 numbers are -5 and +4. So this becomes 2x squared minus 5x plus 4x minus 10 is equal to 0. So now I can group it. I've done my split, so now I'm going to group. The greatest common factor here is x, and I'm left with 2x minus 5. Greatest common factor here is 2, and I'm left with 2x minus 5 equals 0. I now have a common binomial factor of 2x minus 5, and I'm left with x plus 2 equals 0. So let me continue on over here. So if 2x minus 5 equals 0, that tells me that 2x is 5 and x is 5 halves. So if x is 5 halves, the denominator is 0 and is undefined. If I have x plus 2 equals 0, then x equals negative 2. So if x equals negative 2, the denominator is 0, so it is undefined. Okay, if I'm asked to simplify an expression, that means that I want to get rid of any of the factors that are in common to the numerator and the denominator. So when I'm looking at something like this, what I notice is I've got my coefficients, I have my x's, and I have my y's. Okay. So this simplifies to negative 10 over 5 is negative 2 over 1. X to the third over x to the fifth, well, I have two x's in the denominator that I don't have in the numerator, so this becomes x to the second in the denominator. And for the y's, I have 2 in the numerator and 1 in the denominator, so that leaves me with 1 in the numerator. Now, if you need help with any of this, remember for my x's, this means x times x times x divided by x times x times x times x times x. So that cancels, that cancels, that cancels, and I'm left with the two x's in the denominator. Same principle for the y's. If I have y to the second, that's y times y divided by y, which means this cancels, and I'm left with 1y in the numerator. Okay, for problem 7, I have x minus 5 over 5 minus x. And this is where, boy, it looks really close, but I can't cancel anything out yet. Remembering that x minus 5 is a factor, and 5 minus x is a factor. But I also remember that if I have b minus a, that's the same as the opposite of a minus b. So what I can do is write this as x minus 5 divided by the opposite of x minus 5. Because following this, 5 minus x is equal to the opposite of x minus 5. So now I have a common factor of x minus 5, so that really leaves me 1 over negative 1, which is just negative 1. Okay, let's see if I can do this. All right, so if I have 4x over 2x squared minus 6x, well, the 4x, I'm just going to leave it as 4x. But I notice here I have a common factor in these two terms of 2x, and I'm left with x minus 3. Well, automatically I see that the factor of x, I can get rid of that. And 4 over 2 that reduces to 2 over 1. So what that leaves me with is a 2 in the numerator and just an x minus 3 in the denominator. So that is my simplified form. Okay, so nothing I can do with this until I factor it. So in my numerator, I notice this has a common factor of 5, and I'm left with x minus 3. X squared minus 9 is a difference of squares. It's x to the second minus 3 to the second. So I can write this as x plus 3 times x minus 3. So I have a common factor, numerator and denominator, of x minus 3, and I'm left with 5 divided by x plus 3. And that becomes my simplified response. Okay, number 10. Got the same situation. I can't do anything until I factor it. I have to factor first, and then I have to get rid of the common factors. Well, my numerator, let's see, 2 terms. I notice I've got a common factor. So I have 3x to the second times x plus 7. My denominator, it's a trinomial, has a leading coefficient of 1, no GCF, so I'm looking for 2 numbers whose product is negative 14 and whose sum is 5, and those are 7 and negative 2. So this factors into x plus 7 times x minus 2. So now I have a common factor, numerator and denominator, of x plus 7, and I'm left with 3x to the second divided by x minus 2. Now I've said many, many times before, but especially as we're learning, the parentheses are not necessary, but it just reminds me that unless I see an x minus 2, I can't do anything. Okay, on number 11, same procedure. I'm going to have to factor before I can cancel. It's tempting to get rid of those, but you cannot do that. So I have to factor first. All right, so in my numerator, I'm looking for 2 numbers whose product is 16 and whose sum is 10. And I think those are 8 and 2. So this factors into x plus 8 times x plus 2. In my denominator, I'm looking for 2 numbers whose product is 12 and whose sum is 8. And I think those are 6 and 2. So this factors into x plus 6 times x plus 2. I have a common factor of x plus 2, so my final answer becomes x plus 8 divided by x plus 6. And again, I leave it in parentheses to help me remember that I can't just do anything with the x's, I can't do anything with the numbers, I have to deal with the factors. All right, if I'm multiplying polynomials, I multiply straight across. Okay, and I also want to factor in there as well. Okay, so If I'm dealing with monomials, really it's just a matter of reorganizing these things. So I'm going to write this as 2 times 5 times x to the third times y to the third divided by 3 times 2 times x to the second times y to the fifth. Okay, so I have a common factor of 2, so that's gone. So I am left now with 5 over 3. There's nothing I can do with those. The x to the third over x to the second, 3 minus 2 gives me x to the first. Y to the third over y to the fifth, I have 2 more in the denominator, so those are the ones that are going to be left over. And that is my simplified response. Okay, on 13, I'm going to do the same thing. I'm going to just reorganize this. I'm going to write this as 2x times 3x minus 9 divided by 5x times x squared minus 9. Okay, so I've got to do some factoring here. Well, the first thing I can do is I can get rid of the x's. Anything divided by itself reduces. So my numerator becomes 2, and I'm going to factor out my 3 here. So 2 times 3 times x minus 3 divided by 5, and this is the difference of squares that we just did earlier. So this factors into x plus 3 times x minus 3. So I still can't do anything with the 2, 3, and 5. However, I can get rid of my common factor of x minus 3. So this final result gives me 6 divided by 5 times x plus 3. Okay, I have 4 different binomials here, so I'm going to have to factor all of them. Okay, so the x squared minus 1 is a difference of squares. So that factors into x plus 1 times x minus 1. 2x plus 10 has a greatest common factor of 2. And I'm left with x plus 5. X squared plus 5x has a common factor of x, and I'm left with x plus 5. And then finally, 1 minus x, I remember, is the same as the opposite of x minus 1. So this is going to be times negative 1 times x minus 1. So let's see what I've got here. I've got a common factor of x plus 5, and I have a common factor of x minus 1. So in my numerator, I have a 2 times x plus 1. In my denominator, I have a negative 1x. Oh, and that's it. So that would be my final answer. Or I could just write 2 times x plus 1 divided by negative x. Either one, oops, I'm sorry, you can't see that. Either one of those is fine. 15 is the same. Trinomial, binomial, binomial, binomial. I've got to factor everything before I can even think about canceling stuff out. Okay, so it's going to be a long one. All right, so x squared plus 5x plus 6. I'm looking for two numbers whose product is 6 and whose sum is 5, and that is 2 and 3. So this factors into x plus 2 times x plus 3. X squared minus 3x is a binomial. It has a greatest common factor of x, and I'm left with x minus 3. Five x minus 15 is a binomial. It has a common factor of 5. And when I divide that out, I'm left with x minus 3. And x plus 2 is a prime factor, so I don't have to do anything with it. Now I can reduce the factors that they have in common. So x plus 2 is a common factor. X minus 3 is a common factor. So my final answer in my numerator, I have an x times x plus 3 and that is divided by 5. Okay, good place to stop and switch videos.